Hey guys, so here's part 3 of the 3.4 Day 2 notes. We're going to be using the horizontal line test to determine if the inverse is a function. So here's example 7. We're going to consider the function f of x equals 2x cubed plus 1. They have already graphed it for us, and that's going to be kind of the same for your homework assignment. The original functions have already been graphed, so you just have to use the horizontal line test to determine whether the inverse is a function. Then we're going to find the inverse, and we're going to figure out domain and range as well. Okay, so let's see if the inverse is a function. So remember, we have to use the horizontal line test. So go ahead and draw this. And when we are using the horizontal line test on the original function, we should only hit one x at a time. So if I move this up and down, or you could go down and up, just depending whatever you want. Notice that I'm only hitting one x value at a time. And even here, though it looks like I'm hitting multiple, no, this is actually increasing as it goes. So, because it passes the horizontal line test, horizontal, the inverse is a function. Okay, so now what we're going to do is find the inverse. So remember our first step, notice we have f of x, so we need to change that to y equals 2x cubed plus 1. Now our next step is to switch the x and y. So now x equals 2y cubed plus 1. Now I'm going to solve for y. So I subtract 1 on both sides. Now I actually need to divide by 2 next. So make sure you're doing your order of operations. And then my last thing is to get rid of the cube, and to do that I do a cube root. So I get y equals cube root of x minus 1 over 2. And that entire thing is underneath the cube root. Our last thing is we need to rewrite this using our inverse notation. So I have f inverse of x. And I just like to switch it because I like to have my variables or whatever on the left-hand side. And we have cube root of x minus 1 over 2. So that would be our inverse. Okay. Now our last thing, and we didn't see this in the instructions, but we're going to do it anyways. Our last thing is we're going to find the domain and range of the original function and its inverse. Okay. So let's determine what is the domain and range of the original problem here. So remember, domain deals with the x. So we look at our x's and look at our function. Notice that basically they're going to go on forever in both the negative and positive direction. And no, hey, we have an x cubed, our degree is 3, that's an odd, and we have a positive leading coefficient. So going back to the polynomials unit, remember when we talked about odd and positive? That means that it's going to go down and up, and that means it goes on forever like that. So here, we're going to go from negative infinity to positive infinity. Now let's think about the range. Now the range should be a little bit easier here. So notice that we continue to go down and continue to go up. So that means we go both up and down in those directions forever. And to represent that, we just use negative infinity to positive infinity. Okay, now let's talk about how do we figure out the domain of the inverse. Well, remember, when we find the inverse, we switch our x and y. Well, because we switch our x and y, the domain and range actually switch. Okay, so whatever the domain was on the original function, That's going to be the range of our inverse. So since the domain on our original was negative infinity to positive infinity, the range on our inverse is going to be negative infinity to positive infinity. And since the range on our original was negative infinity to positive, that means our domain is going to be. Okay? So just remember that. Whenever you look at the original, just swap that, and that'll be your domain and range for your inverse function. Okay, make sure you work on the homework assignment. If you have any questions, make sure you contact me. I'll see you guys later.